Hello, everyone, and welcome to another edition of the MLOps Community Meetup. I am the host, Demetrios Brinkman, and today I am joined by none other than Oz, and your last name is
Gencoglu.
Gencho. There we go, which is not an easy one to pronounce considering the spelling of it. And we're going to talk about the POCs, and first off, I think it would probably be interesting for people to learn about how you got into tech and maybe what drew you to Helsinki, where you're at right now, and then how you started going down the path of machine learning.
Sure. Well, I studied basically electronics engineering in Turkey during my bachelor's, but already in the third year I was moving to signal processing, programming, information theory, estimation theory, more on that side, pattern recognition, and actually machine learning. And then I came to master's to Finland, and during my PhD studies, I co-founded my company, Top Data Science. And last 5 years, we have been delivering about 70, 80 machine learning solutions to various industries, various companies. So we are not a product company, but we are good at solving other people's problems with machine learning. And our clients are good at having problems.
That's good. It gives you job security.
Yeah.
That's awesome. So let's talk a little bit about that statement that you just said. It's easy to get problems when it comes to machine learning. What are some things, some patterns that you've seen repeated when you go into the client, and maybe it's something that is an obvious one or it's not so obvious, but things that keep coming up?
Yeah, I can of course talk a bit about this kind of recurring patterns throughout all these 5 years of 78 machine learning solutions. One thing is that I would like to clarify that the client's expectations 4 or 5 years ago is quite different than that of now. Due to the increased understanding of what machine learning is and capabilities, advantages, disadvantages. So it's hard to say that it stayed static during these 5 years, but the common pattern through these let's say demands is that trying to automate or semi-automate a task that is extremely repetitive. Like people understand obviously that when you basically solve a repetitive task in an automatic way, that's scalability. Basically, that's automatically the whole scalability thing. That is one thing, and secondly, this boring aspect of it, especially if a task is rather boring and you kind of have to do it, filling certain things, looking up to certain text, looking at camera feed, you don't want to do that. And that kind of repetitiveness and boringness are the aspects that clients first create their backlogs. Then comes, of course, the reality of this cost-saving side, which comes the second filter, etc. But these are really recurring patterns or these low-hanging fruits where most projects actually get some kind of results.
Yeah. So I love what you just said there, because when you automate a repetitive task, that's scalability.
Yeah.
And also the change, the evolution that you've seen. Maybe you can speak to that a little bit for a second before we dive into the whole POC notion. What was expected of you in 2016 and what is expected of you now?
That is absolutely quite important, I think, to ask, because obviously we can then extrapolate. If we can look at where we have been, it's a bit easier to predict, at least short term, right? So first of all, I see a lot of questions actually, especially from newcomers, maybe new graduates or people who are trying to migrate to data science, machine learning field, that they are quite confused about the titles. There's machine learning engineer, machine learning scientist, data scientist, senior data scientist, principal data, this whole thing. And what's worse, those things do not mean the same thing between company A and company B. So there's no common definition. So whoever listening, if you feel a bit overwhelmed, that's completely normal. It's kind of a moving thing, those titles, throughout the whole industry, as well as even inside company, I would say. That's one. And 5 years ago, those titles, or what is expected from a data scientist, machine learning scientist, or a machine learning consultancy company, or an internal team who is doing machine learning in a large corporation, was quite different. Back then, it was more about POCs, proof of concepts. Let's start with something small. Let's understand how this machine learning things, how does it work. So this is usually this was the pattern, and either operationalizing or putting things into production was not even planned in the first place, or it was so that you don't even know that what you don't know, that it was just, hey, let's just start with some proof of concepts and learn a couple of things. So through these 5 years, it has of course moved more and more to, hey, let's productize things, or start building a product level solution right away from the beginning. More and more, there are still lots of proof of concepts, which I will talk about quite a bit, but this has been the let's say trend, which is a good thing.
Yeah, because people are starting to realize that they need to put it out into the wild if they really are going to get the value out of it, I imagine. And so they're coming to you with that idea of, let's make sure that we can productionize it before we even begin thinking about the whole journey of it. So let's talk about proof of concepts and the idea of POC hell. And so the proof of concepts, as you mentioned, years ago, it was the go-to. It was what everyone was doing. And it was a starting small just to see if there was anything that could be, or if there was any piece of the business that could benefit from machine learning. And so what is that process like? And then I love that you mention the significant amount of these POCs don't get out into the wild. And so where's the disconnect there?
Yeah, that is absolutely what I would like to emphasize in today's talk, that there's nothing wrong like with running a proof of concept, but we need to understand that there's this diminishing returns of I see this trend in the industry. Large companies, they are in this POC hell, or they are hitting the POC wall, or maybe POC loop, that forever proof of concepts, forever AI proof of concepts, never make it into production. To me, to be very honest, a proof of concept failing, not being very successful due to this and that reason, accuracy is not there, or maybe you didn't get the exact talent or right type of people. A proof of concept failing and not making into the production, that's not interesting. That's a good thing. Like that's why you do the proof of concept, right? A proof of concept being successful and not making into production. That's very interesting to me. So I would like to talk about that actually.
Okay.
Because I see that a lot. Proof of concept, proof of value, whatever you call, you get something working. Yeah, you do your nice presentations. Everyone is like, wow, cool, machine learning. We detect these things, predict that. And it never operationalized. Now that is quite interesting, and I would like to a bit dig into that in today's talk.
Yeah, let's talk about that. So you get it working, it's going well, but it doesn't get what? It doesn't get the buy-in from others, or it's just too hard when you have to take it to the next step and put it out into the wild?
I have kind of through these years diagnosed a couple of reasons why this happens. Number one would be that why does a proof of concept for the metrics that you judge a proof of concept was successful and never make it into production? One is because the main reason is because proof of concepts or this whole initiatives are started and created by enthusiastic people, maybe mid-level managers, not company like high from the top, let's say, like not executive level, not company strategy level. So it's a couple of enthusiastic people who know this thing is coming and who would like to play around with this. Hey, let's start. This whole world is talking about either fear of missing out or really genuinely interested in creating value. I don't care. But it's not enough because they don't get the green light for the big thing, for the productionizing in terms of timeline, budgets, let's say support from IT, or finding talent, etc. So almost all of the projects that we have put into production, the client had a company level strategy, executive level strategy of we will be data driven, we will be utilizing these technologies. Almost all. This is one. So basically top level commitment, it trickles down, let's say, right? So this is one reason. Second reason would be that a proof of concept being successful in terms of proof of concept metrics. Hey, we reached some accuracy. Okay, cool. And we had trained this, we collected this much data, annotated it maybe. Yeah. That doesn't guarantee that those metrics are relevant for production. So this is, there's this mismatch in understanding. For example, let's say you are, you want to, let's say computer vision, right? You want to detect certain objects. And you want certain, let's say in the production line, there are some defects, you want to catch them. Obviously, you want a high accuracy, maybe low miss rate and things like that. So you have a proof of concept, you annotate lots, you collect lots of data, annotate it. Your data scientists or some external data scientists train models, and you get a model. But then that's kind of it's working. Maybe you can call proof of concept successful, but then you realize, what does it take to make it into production? You need to have it real time. Now that's quite different than having a model. Running a model in like close to real time speed in an environment, let's say in the middle of nowhere, you don't have internet, there's no cloud. That's a different ball. That's a completely different beast. You don't have GPU, maybe, right? You maybe like you need to. What do you need to do? You need to optimize the model first of all from the software side, quantize it. We do model pruning, compression, all the mathematics. Then you can optimize for a specific hardware. You can do quantization, some inference engine. So these things if you don't plan during the proof of concept, it will never make it to production. So from the beginning, data scientists or machine learning scientists, machine learning engineers should be aware of these constraints, like as a holistic view. So basically, the whole is greater than the sum of its parts. So it's not like we will first have a successful proof of concept, then we'll see, and okay, then a pilot, we will judge the pilot only with pilot's metrics, and then if it works, product. It's not like that. You need to inject the production level metrics, success metrics, bit by bit to your proof of concept mindset.
So that reminds me a lot of something that Laszlo, who was on here a while ago and who is in the community Slack, very vocal, and he said for him, it's really important to get something working as fast as possible. And then you iterate on top of it and you really nail down into it. But I like this idea of the whole is greater than the sum of its parts, and really taking the productionizing metrics from the very beginning, so you don't have a successful POC, but really it's not successful when you go and try and productionize it. I think that is a huge learning right there. And maybe you could talk a little bit more about that, like trying to get something out as fast as possible just to see if it works.
Yeah, so this kind of creeping in the production metrics in your proof of concept mindset, it's not only a technical thing, it's really a mindset. So when you're approaching a project, a problem, it changes your whole paradigm when you have at the back of your head, hey, this thing will be running on a modest hardware close to real time, this false negative rate, whatever. And this and it will be used by this kind of people. So really the holistic view, the budget probably will be this. If it's on a cloud, oh, if you productionize it, actually it will cost this much. So I shouldn't use the state-of-the-art largest model, because then, so it changed the whole mindset. And I like this iterative idea because if, as a consultant, it also decreases your risk for the client communication, because this is a trend in consultancy. Actually, let's say not only consultancy, but you can be working in a data science team in a large corporation. You are reporting to, let's say, problem owners or stakeholders who own the problem actually. Here's what happens. In the beginning, you get the data and data scientists show like nice plots, right? Hey, this is what you have. And the client or the problem owners, whoever that is, they think progress is made, but it's not. So that's not progress. And then you actually start building models, like quick, let's say maybe some baselines and stuff. But I mean, there's not much to show to the client for some weeks maybe, and the client thinks nothing is happening, but other way around. It's actually, it's quite important to get something quickly done, and then towards the end of a project life cycle, then you maybe productionize it, put it in a UI or live, and then client, oh, lots of things happened, but actually it was more like wrapping things up. So having a fast working thing and showing something rather quick. Nowadays, there are many tools actually to even mock up a production, let's say mocking up how it will look in production. It also decreases your risk level for the stakeholders and the problem owners. And it also decreases their anxiety because it's important. You are co-creating this whole thing.
Well, I want to get into a little bit more of that, like how to not sink a bunch of time into something. But I think there's a greater question here for me, which is, and you mentioned a little bit of it, like what to keep in mind when running POCs, but do you have a framework or something that you try and go off of to determine a successful POC? Like you mentioned, keep your eyes on the productionize and or being able to productionize it. But what are some of these? Do you have like a criteria on really what that means?
We don't have a decision tree that you follow this, and it applies to every case. Obviously, it's not like that. But I can give a couple of tips indeed. So even though it's for a data science team or a machine learning team, engineering or science part, even though it looks like it's actually less risky to just start with the proof of concept, it's not. So even before starting the project, before writing a single line of code, we like to make the problem owner who's coming with the problem to you, or the client, we like to make them think about what they would like this to be at the production. So basically trying to get their expectation management, trying to get their expectation already before starting the project. So it's not like, hey, let's just get the data and let's aim this accuracy. It's not like that, but it's more about how much budget you think you can spare if we put it into the production. How about maintenance and support? Do you want our team to do it, or do you have your means? How about speed? How about fairness? If an algorithm makes like there's all kinds of biases, do you get into trouble? What are your constraints regulation-wise? Personal data privacy, can your model leak data? Like, ask these questions so that they think, the problem owners first think, and then you get a holistic picture, so you have a better plan to make this work. So that's what I mean by not always keeping the production in mind, even in the beginning. So this is I think quite crucial. Otherwise, you run proof of concepts after proof of concepts.
Yeah, and then there's no surprises later.
Yeah.
I think that is immensely important point again that you're touching on, is try and get the stakeholders and the various stakeholders. I'm sure you're not just talking to one project owner, but there may be a few within the whole project, and try and get them to really explain to you their vision so that you can take that into account and then ask these detailed questions about, what is there any regulation around this? What is the data privacy? What kind of, like you mentioned before, are we going to be running it on the cloud? Are we going to be running it on devices? These basic questions that may not come to mind right away, especially if you get really excited and you say, oh, I know how to solve that, right? Like, I've got this incredible way of doing this. And then you just go and then a few weeks later, you come back with a solution and it doesn't hit the nail on the head. And so let's talk a little bit about how, besides using your spidey senses, and can we pause here for a moment just to acknowledge that is a damn good looking shirt. Everybody that's listening in the future and is on the podcast world, you want to go watch this video just to see that shirt. Wow. Yeah, we're going to have to talk later because I need to get me one of them. Anyway, I got a little sidetracked. But let's talk about how you make sure, besides using your intuition, to not sink too much time into a POC. You talked about that earlier, like, oh, well, people think that maybe nothing's going on, but there is something going on. And how can you get to this point where where, like you mentioned, there is that law of diminishing returns within a POC where it's not going to get much better, but if you want to, you could probably squeeze out a few more weeks and continue working on it.
Yeah. So one thing before, as I mentioned before, even the technical part is that understanding and making the problem owners understand what we envision together for the production. And for example, let's say you have a proof of, you have an idea of a proof of concept, you have a problem, and you know pretty much what kind of approach you would do. So you will implement this, okay, this way, and okay, there's this kind of data, maybe you do this and that, take care of that kind of problem, issue, etc. But just making the client or the problem owners understand this law of diminishing returns is quite important, because they don't usually understand. Why should they? That's why you are the expert. It's literally your job to let them understand that reaching a certain error rate, halving it if it takes X amount of time or budget, another halving it takes like it's power law, right? Or even exponential, that it takes much more amount of time to squeeze some percentage more. And if you want to squeeze a couple of more, it's even, is it worth it? And here's the important thing, saying this, just like how I said to them before doing the project. So before starting the project, this is because this is how it works across whatever. If you are doing NLP, computer vision, I don't care. This is how it works, and you know that. So you should say it. You should communicate it. This is just one aspect. This is just accuracy, maybe. Let's say again, in terms of speed or something, you can increase the speed, of course, throwing more compute, let's say the inference part, doubling the speed, okay, another doubling. It's not linear, so it has a cost associated with it. You know it. You know it. Why don't you tell it, right? So this puts everything into a completely different perspective. So this law of diminishing returns, it is applying to a project itself. That's one, as well as for an organization, that you get diminishing returns of proof of concept after proof of concept as well. So there's this like a higher level thing about that.
Yeah, let's jump into that proof of concept after proof of concept, and the idea of the proof of concept hell, and I liked how you put it, you just get stuck in a loop and you don't really get anything out of it. Can you explain that one?
Yeah. One reason this happens is, or another reason is because in the organization, you haven't created your backlog of ideas, backlog of, let's say, problems. You were lazy. You just thought, hey, this is a problem here, let's just start with this. But is it the optimal problem to start with? Is it the best match for machine learning, really? Or is it just fancy and cool? You need to ask that. So the clients who did their backlog of really sitting down throughout the organization, what projects or what problems we can solve with machine learning. It doesn't have to be visible immediately, but somewhere at the back in some process, there's something you can optimize. So when you actually sit down several people and let them think for some hours, for some days and week, you get like hundreds of ideas and backlog. And if you just do the most obvious one, okay, these are the 5, hey, of course we should automate this, usually that's not the most optimal for machine learning, so for production level. So basically, if you create this, if you force yourself to think about what are the problems that can be solved with these technologies. It increases your probability of hitting the jackpot throughout your backlog. So
Great.
that's one thing. Don't start. Think, write your backlog. It will make you think clearer, like a bit more holistic, a bit one step back. This is what I advise to everyone.
That's a huge point right there. Like the idea of having the lowest hanging fruit and really making sure that you get what is going to be the most effective. This reminds me of when we were speaking with Luigi a few weeks ago, and he was really hitting that point home. Really like figuring out what is going to be the best use case for machine learning, and from not only from your point of view or the manager's point of view if you're working with a manager, but from the business point of view. And maybe there are pieces of something that you see as a problem and you think, wow, I could fix that with machine learning. But there is a whole nother problem that is going to be much more important and valuable for the business that needs to be done. So having that holistic view is really like a key and crucial aspect. Now I wonder about how you can get that holistic view. Is it just from talking to various stakeholders? And I like how you said it. Companies are lazy and they haven't really thought about what ways we can use machine learning within our company. And so do you go in there and you just ask them questions again? You say, all right, let's see, what are some of the most painful problems that you have, or what are some problems that you have right now, and we can figure out if machine learning would be a good fit for that.
In our case, many clients come with their own problems. We just kind of make them question: we need to understand that, is this suitable for machine learning? Because they think, they come to us. Or the other way around, in a corporation, you typically ask various stakeholders, as you mentioned. You talk, but not only ask, hey, you can't just go like, hey, do you have any problems that can be solved with machine learning? Because they don't need to know what machine learning is. So what I mean by asking is really explaining these can be done. Here, what we have done or other people have done in a reasonable amount of time or budget. Do you like a bit spark up, not in a really formal way, but really spark up conversations? And then there's always somebody, oh yeah, actually we've been talking about this 2 years ago, that there's this database. Like it comes up in that kind of chatter where you consciously let them know what can be done successfully, and then they start thinking, instead of asking, hey, do you want to automate? What are the things you want to automate? Because then they will tell the most obvious ones, which I mentioned. Just you come up with 5 things, but there's this at the back, there's this really the project that, or the problem that if you solve it, that's the business value.
So many good points here. Now, I am wondering on when you're looking at a POC, like, and you're trying to scope it out for a team. I've had some people that I've talked to in the community, and they've come and they said, hey, look, we've got this model that has been given to us, and it's like the DevOps team. And the model's been given to them by either the data scientist or sometimes even consultants. And they say, now what do we do with it? Do you have any good answers there?
Yeah, for the operationalizing side, this is a bit similar to having the problem owners in the beginning, already before starting anything. It applies the same with this synergy between data science teams and engineering teams, right? You would like to get the idea of what the machine learning engineer team, or let's say DevOps teams, how they envision this in production, because that's not your expertise as a data scientist, or vice versa. So having these different stakeholders is also in your team. Maybe it's not stakeholders, but different kind of opinions and expertise already early in the project. It's quite crucial. And one thing is that this kind of, let's say, data science part and the engineering part, it's not, of course, a clear line there. So, and nowadays there are so many tools that a data scientist can also a bit migrate towards the other tasks by using these tools, or vice versa. So it's becoming more blurry and gray, which is a good thing. But it's always a good advice not to assume that, hey, this is a machine learning project. It's a data science thing. I build a model. What's the big deal? You put it into production. It's not like that. So from early on in the project, putting people into the same room or in a same spot, and hey, this is what we are envisioning. What do you think? What is your opinion? Is this scalable? Does it make sense? Can we even put it into production? And also nowadays, I think back then there were lots of tools to build models, and that was an issue 5 years ago. But now it's not an issue, right? And putting things into production was an issue maybe 1-2 years ago. Now it's getting solved. Now the problem is operationalizing it, maintaining it, supporting it, preventing concept drift, preventing your model becoming worse throughout time. So the teams also have to adjust themselves to these new tools and new paradigms and different needs of the whole industry.
There have been a few other consultants that have come on here, and we've heard a lot of horror stories. And I'm wondering if you've ever had it where a company asks you for something and then you inevitably get to the point where you say, okay, well, we would need such and such data for that to happen. And they say, yeah, sure, we've got that data. And then you go and you actually poke around and you find out you don't have that data. Are there any stories like that you can share with us?
There have been a couple of cases, not that bad, but there have been cases that the client, let's say, underestimated either their data amount or data quality or the effort to collect and annotate that data. This is also a bit on the consultant's part, so that I think it's important to guide the problem owners. Hey, there are these tools you can collect easier or check the quality of your data or annotate it. If a consultant doesn't want to do the annotation or even cannot do due to domain expertise, it's important to help the problem owner or the client. Hey, here's an open source tool, nice. Let's say it has active learning. You can annotate in a fast manner whatever images or text. So it's important, but even sometimes that's not enough. You realize that a bit towards the middle of the project, it's gonna take quite a bit of time for the client to collect this kind of data. This happens especially when the phenomena that you are trying to solve is a rare phenomena. It's some kind of maybe outlier detection or abnormality detection or detection of rare diseases. It's so rare that it's a good thing. It's rare, but then there's the other side that you don't have data for those cases, or you need to wait many years so that people get that disease. So it's a reality of I think every consultancy.
And again, it comes back to one thing that I think is fundamental about this talk with you is the open communication that you need to be having, and you need to be constantly making sure that both teams are on the same page. And so maybe you have some tips around that besides what you've already spoken to.
Yeah, when I mean by I really emphasize this open communication for both sides, right? So it's a mutual thing, because it's not like them versus us, or it's like you are in the same team actually co-creating, trying to solve a problem. And from a consultant side, all those things that trying to decrease the anxiety of the problem owner, of the stakeholders, anxiety of not knowing what machine learning is, its capabilities, its limits, being open about it, not exaggerating, not trying to sell snake oil, being very, very transparent about it, and what can go wrong with these algorithms if you put it into production. Um, what are the errors mostly like? Like, it's not just we have this much error rate or this much accuracy. Why? Like, a bit trying to explain, oh yeah, because of this thing you see in this image, the algorithm thought it was whatever. Um, so a bit digging down the hood instead of covering, like making things black box, more like explaining them, being transparent. How did you operationalize that? How did you solve that? What is the working ways? What are your working ways? How do you work? Invite the clients to your code base, right? To your repositories. Like, hey, you see the progress every day. We are doing this. This is from your side. From the problem owner side, sometimes there's a lack of communication in such a sense that clients try to hide their this kind of long-term vision, or even they hide their strategy. Of course, strategy is it's kind of a sensitive thing. On the other hand, you can't expect to co-create something. Hey, we have our strategy and long-term vision. It's none of your business. Just solve this. It's that's not healthy. So knowing about the long-term plans, long-term strategy. Hey, we are committed to these technologies or this vision for this many years. We are planning to automate these things. We are planning to have this much budget in this year, next 3 years, 5 years. We are planning to hire these kind of people, IT, software, maybe data science. So knowing those plans, it's quite important from either an internal data science team or an external consultancy, because then you have a better idea. Then you are. It also decreases your anxiety in that sense. So this kind of open communication is really from the technical perspective, but also even business and strategy perspective. As a data scientist, I was always interested in the big picture, the business, the strategy, and it's not just like I only talk tech or numbers. That's not the way.
Yeah, well, there's a lot that goes into, and what we've spoken a lot about here on the translation part from that business side, and saying this is what our goal is, and then being able to translate that into something that you have a use case of machine learning for. And so maybe you have some tips and tricks on translating and how to properly understand that when you need to get from point A to point B.
So first of all, thank you for bringing this translating up, because I believe the most crucial part of today's machine learning scientist, machine learning engineer role is not actually building a machine learning model, training a machine learning model. this might be controversial, or putting a train model like somewhere to some server. But I think the most crucial part is translating a real life problem into a machine learning problem. And this is why is this so crucial? First, because it's a scarce talent or skill, because you don't learn it during the formal studies. In your projects or in like this kind of courses, you are given a data. Somebody did that translation. You don't exercise that. So that's one thing. And secondly, you can't learn it in a textbook, right? It's the same that you don't learn that, okay, there's a real life problem. We have this process running, and how to turn it into a machine learning problem, or do you even have to turn it into a machine learning problem? I believe this really comes with this intuition that you can't learn from textbook or courses, that you do that as much as many times as possible, and you have this intuition, yeah, that won't work, this is how we should do it. You just know after like 50, 60 projects, 50, 60 times doing that. And my advice to people is, especially for example for new talent, I think we have almost always hired somebody who picked a problem from real life, collected his or her own data, build a model, put it somewhere, just a very, it doesn't have to be like just end to end, started from the problem, not just downloaded this data set or found this data set, but started from the problem. And they showed in their CV, hey, there was one colleague that we hired. He wanted to predict the optimal place to pick blueberries in Helsinki. So he was just going out, like collecting some data, like basically blueberries, and okay, these places have a lot, and building
That's
a model.
amazing.
This is the thing, because now this person knows how difficult that translation problem, this data collection problem. This person is a perfect consultant, because he can emphasize, he has empathy for the client, for the problem owners, because he's not just given a data set and building a model. This translation part is, I think, extremely important, and it's not like you just practice it. You go after in your everyday life. I advise go after the problems that try to translate into machine learning problems, that like automate something, and realize how difficult it is, and get some insights.
Yeah. And I feel like it is so easy to miss the mark on this just by a slight mix up and not being able to translate it correctly, or going right when you could go left. So it is a rare skill. I agree with you. I see some people in the chat are also saying they agree with you wholeheartedly that this is something that they don't teach you, and you can't learn in a textbook.
No.
You learn this from experience. You learn this from doing it many times and failing, and then you eventually start to see and you start to understand. There was a great meme or flow diagram that I saw, and I'll see if I can find it and put it up for everyone before the end of it. I'll ask this question to you now, and then we'll go and I'll find it. Someone posted it in Slack about this translation process and what you can expect and how to translate. And so while you answer this question, I'll go find that. I'm wondering, I know Denmark is like one of the most expensive places in the world, but realistic budgets for small POCs and how you calculate budgets for POCs.
In Nordics, in here in Helsinki, in Finland, or Denmark, Sweden, I would say that is a bit different than other parts. Typically, if the client has done this before, meaning that has exposure to machine learning projects, either by their internal team or by some external consultancies, you need at least like 1 month of work. This is, I would say, 15, 20, 30 days are, I would say, the minimum proof of concept time. Really, this is about just proof of value, let's say.
Yeah.
Because then the client knows that to get something working, you need the data. Even to get some result, you need the data ready and stuff. So if this is the first time the client is doing it, there'll be problems. So there'll be all kinds of bumps. So double that time or triple. So this is my let's say time budget for a proof of concept. But once again, that doesn't mean things go into production.
And this is with asking all of these questions we've been talking about this whole time. This is when you think you've got everything well laid out and you set the foundation correctly. So even if you are working with someone who hasn't asked these questions, or you haven't asked these questions yourself, then you can tack on a few more months there, I imagine.
Absolutely.
So I found I think someone put this in our Slack. I am just showing you right now. This is so the business question: which of our current freshmen are at risk of not retaining, and retaining, and how might we intervene this semester to improve their chances of continuing at our institution? And the actual analysis question is: which first-time, full-time, degree-seeking freshmen enrolled this fall are most likely to be continuously enrolled through next fall, and what factors appear to be correlated with the outcome? So I find that fascinating because it really makes you take the question, and this is exactly what we were talking about, right? The translation of it. It's really easy for someone like myself or someone that has more of a business vision and they're not steeped in the data science in the day-to-day to ask questions like that. And then you have to take that question and really make sure that you tack on all of these pieces so that you can understand the question fully.
Absolutely. That translation, I see, that is the greatest skill in this whole industry. That's the greatest skill to have, because that you can't automate with auto ML or whatever. So it has a kind of a bulletproof or like this. It stands the test of time, because that will be needed basically all the time.
Amazing. Well, Oz, this has been fascinating. I am grateful that you came on here and talked to me. It's been a long time coming. I know I wanted you to get on here for a while because I've been loving what you do. And I suggest everyone that does not follow him on LinkedIn, get on LinkedIn, give him a follow. You're creating all kinds of value. Also, you run a meetup in Helsinki?
I'm sometimes talking in different meetups, but I'm not organizing something.
Okay, I was mistaken then. Well, you have a lot of great material out there already, and if anyone wants to reach out to you and continue the conversation, what's the best way of doing that?
Yeah, Oguzhan Gencoglu at LinkedIn, I think, and my name.surname at topdatascience.com. Always email me or reach out to me. Super happy to be here, and thanks for the invite once again.
This was excellent. Really appreciate your level of understanding and the experience that you have on this. I mean, there's been some incredible quotes taken away from this. When you automate a repetitive task, that's scalability. the whole is greater than the sum of its parts, not looking at these little pieces of, oh, let's do a POC with the model. Now we do another POC with this piece of it. We do another POC with that piece of it. No, you got to look at the whole thing. And I think that was probably what blew my mind the most, is start with the end in mind. I've heard it so many times, but it's always good to hear it again, right? Start with the idea of, we're going to productionize this. So what do we need? What is going to be crucial for that? Then just managing expectations, having that communication be open constantly and continuously. And I love the idea of the backlog of problems and what problems are best to solve with machine learning, trying to figure that out and trying to make sure that the people you're working with are really hip to what the main problems are and how they can be solved. So getting after that low-hanging fruit. Thanks, Oz. This was amazing.
I appreciate it. All right.
See you later, everyone.
Thanks
for
everybody.
joining us.
Thank you, everybody. Bye-bye.